It's friction and types of friction, and we will discuss fundamental forces in nature, and then we will discuss do some more problems in this. Friction, what is it? It's just these are the definitions that people have already seen in your class 9th or 10th, and they are just the thing, nothing extra, nothing more than that. Now see a friction, a force that comes into play whenever a body moves or tends to move over the surface of another body is called friction. It always opposes the relative motion and acts parallel to the surface of contact. Here, they have talked only about, in your syllabus, they have only talked about, just a minute, yes, they have talked of only those bodies which are in translation motion. Suppose this body is moving in this direction, and there is a surface here which has got friction, then the force of friction will be in opposite. We are not talking about rolling friction because that is not in your syllabus. In which direction the rolling friction will be, in this direction or in this direction. We are not talking about this because this is not in your syllabus. So let's remove this. We don't have to talk about this. Then the next thing is that you need to know about the molecular theory of friction. What causes friction? Suppose this is one surface. This is the surface. Wait a minute. This is the surface. This is the surface like this. And if you see the molecular part of the surface, then this is somewhat jigsaw type of a surface. And the surface kept on it, the body kept on it also has a surface like this. These and this get they get attracted to each other, and there is a adhesive force between them. When the body tries to move over it, it has to overcome this resistivity here, and that causes the friction. That molecular thing has been molecular theory of friction has been discussed here. You can pause this video and write down the notes if you want to. These are very basic and elementary thing which does not need any discussion. Now let's come to, basically you have already what I have told you here in this diagram. The same thing has been a little bit explained out here. Now what is static friction? Here I need to talk a little bit in this static, limiting friction and all this. In this static friction, we have a force. The force of friction is always less than mu s and n. Now what is this n? What is this mu s? See, the coefficient of friction of the surface is denoted by mu. It is to be written like this way and pronounced as mu, the Greek alphabet, right? And this is the static friction. Suppose a body is in contact here. Suppose the body is here on this. So the body's weight will act in this direction. And I have done problems in the earlier video also. And the normal reaction is here. So this is your frictional force, which is always less than this. Fine, that is the static friction. What is limiting friction? The next part is limiting friction. Now let me make you understand the maximum force of static friction which comes into play when a body just moves over the surface of another body is called limiting friction. This is just the definition. What I need to tell you is something more than this. I need to tell you I need to show you how things are. I mean to say this. Let's understand this way. Let's understand this way. See, I'm talking about limiting friction. Wait, so the dynamic friction is it? This is the limiting friction. Now see, what will happen is this equation, which you are seeing in the above this part, this will now become F max, maximum friction, and we can call it just the normal F, no problem. We will now write this equal to exactly mu s n. This is now this. Let us understand this with a little bit of an example and a graphical situation. Things will be much more easier. Now this is your y-axis, this is your x-axis. This is the applied force. Let us write applied force. A means applied force. Applied force. This is your applied force, and this is your frictional force. Till you reach, the limiting value. Let me put it here. Till you reach. Sorry, let me put it here. Yes. Till you reach the. Till you reach. See, take an example. You have a cycle. You want to pull it. It won't just move with a little force. You have to apply a little more force so that the cycle starts moving. So till you apply a little force, at that time the frictional force and the applied force will remain same and will be exactly 1:1. And at a certain point, wait, my line is becoming a bit tilted. Wait a minute. Let me draw a straight line like this. Till certain value of a force, when the cycle is about to move, this point is where you will have F max, and this is that value. This is that value. And now after the cycle starts moving, immediately it will fall down straight, and then it will become constant. This is the kinetic friction or the dynamic friction. Here the dynamic friction comes into play. Here it is the static till here it is Fs. Fs is still here. This is Fs line. This is your now F kinetic. F kinetic is kinetic friction due to kinetic motion. This here you will use the formula mu Kn. The only difference is this, nothing more. See, I'm repeating it once more. This is your y-axis. This is your y-axis. This is your x-axis. Basically, the x-axis will show you applied force, and the y-axis will show you the frictional force. Now what happens is that, suppose I told you an example of this cycle out here. You have a cycle, you're trying to push it. You have a cycle or a body, you take a body, fine, you take a body, or you try to push it. It won't move. You apply a little bit more of force, just a little bit more of force. It just starts moving. That is this point. Before this point, whatever force you applied and whatever the frictional force, they were all same. Both of them were same. F equal to F applied till here. At this point, this will become F max, which is this. Before this, that is this, and this quantity will be same as this. They are directly proportional till this portion, till this portion, till this portion. After this, will reach a maximum level here, and then it will again, when the body will just slide, it will come down, and then it will remain constant till the body is moving. This is what it means. This is where this idea of maximum friction comes into play. Mostly, you will use this formula. Mostly, you will use this formula. In some cases, we will see in banking of tracks and some this other, we will use this inequality symbol. That when we will do, we will see it. Now, next is the dynamic friction, which is also called the kinetic friction. Let me write, this is also called as the kinetic friction. I see I've written dynamic or kinetic friction here. So this is the same thing, nothing more in this. Then these are the laws of limiting friction. What are the laws? It is independent of the surface. It acts tangentially. What is tangential to the surface? See, if the surface is like this, let us say, it will be a tangent. You have seen a circle in your class 10th, and here is the tangent. So this is the way it will act tangentially to the surface. It will always be, and the normal reaction will be in this direction. The thing will be tangentially to the surface. T is the tangent here. Let me write T tangent, and this N is normal reaction. Some people use N. I told you in the earlier video, I use R or N, that is your choice. You want to use N, fine. You want to use R, fine. I'm just leaving it N so that you don't get confused. Now, these are your limiting friction depends on the nature of the surface. Limiting friction is directly proportional. These are all what I just explained right now. These are equations. Now, these are the laws of, wait. These are the laws of kinetic friction. I just told you what is kinetic friction. Opposes this. The value, you just have to copy it down, stop the video and copy it down. Nothing more than that. These are very elementary definition. What you need was this concept. You needed this concept. Exactly when to use what. This concept was needed, basically. Now you see, I told you here it is, you can see I have written mu k r. I have here written mu k n. It hardly matters. I told you n and r are one and the same thing because I'm talking about normal reaction. In some books they use n and in some books they use r. So it hardly is a matter of sign convention, nothing more than that. Now, this is a rolling friction. There is something about rolling friction. Rolling friction is nothing to do about rolling. It is basically a misnomer. It has nothing to do about rolling. It depends upon a hard and the softness of the surface. Suppose you roll a ball on a carpet. Suppose you roll a ball on a carpet. I'm just explaining on a carpet. This ball, wait a minute. This ball is on the carpet. This is the carpet. And suppose this is the ball, same ball on a hard surface. Let's say your floor of your house. Hard surface, let's say the floor of your house. See, if you roll the ball on the carpet, it will go till here and it will stop. While if you roll that ball on your floor, in your at your home or at your any place, it will may go still further and then stop. So rolling friction has nothing to do with rolling. It only depends on the hardness and the softness of the surface. Harder the surface, rolling friction is less. Let me write down. Harder the surface, harder. Harder the surface, harder the surface, lesser is the rolling friction. Lesser is the rolling friction. By rolling friction, by the way, it has nothing to do with rolling. Rolling friction. It's just a misnomer. I mean to say a name given to something which is not basically it should have been given. That's what it is. Then causes of rolling friction, the molecules, what I explained you here exactly, somewhat like this. This what I explained you. in this molecular theory of friction. That the same thing is there here. You can just pause this video and write. I'm moving it here. This is your thing. You can pause it and write. Now note one thing. The value of coefficient of friction is always between 0 and 1. And this is the this place. This is the static friction. See, mu s is the coefficient of static friction. Mu s is coefficient of static friction, okay. Then mu k is coefficient of kinetic friction, because when the body is in motion, and mu r is the coefficient of rolling friction. They are just different values. And remember, this is always the rolling friction is always less than the kinetic is always less than the static friction. Now, advantages of friction, very well in elementary classes, you have already read this. So hardly I'm going to discuss in this. You can stop the video and you can write this down. And your disadvantages and advantages of friction. Disadvantage of friction, wear, tear, heat, light, damage to mechanical parts, then all this stuff. Method of reducing friction, you have been reading from, I don't know, from class 6th or 7th. By polishing, by lubricating, by streamlining, by using ball bearing and all that. Now, something new for those who didn't have physics in their class 11th and 12th. This is your fundamental forces of nature. Though the last two are more important for you. Already in class A and 9th and 10th, you have been introduced to gravitational force. You have been introduced to electromagnetic force. So let's see what it is. Gravitational force, these forces are always attractive in nature. These forces are universal in nature. The weakest force in nature. Why weakest? I'm telling you. Suppose your friend is here, your friend is standing here, you are standing here. There is a gravitational force between both of you. You are pulling each other, but it's so less that you don't come and stick together. That's the point. See, even between you and the earth, suppose this is the earth and the earth is pulling, you come and you fall down towards the earth, but you don't stick to the surface of the earth. You can move here and there. That's the thing. It's the weakest force in nature. Inverse square, this obeys inverse square law that you've seen in class 9th also. And this is the expression you have already seen in class 9th. I'm not telling you. They're central forces. What do they mean by central forces? Inverse square law means, what do I mean by inverse square law? Let me discuss this point. See, this is your force and this is your R. I told you I'll like to tell you later on that how does this F and R vary if F is directly proportional to 1 upon R square. So the graph of this would be something like this. Something like this. As distance would go, it will become almost zero. This is the type of graph for this one. Now see, these are central forces. What do you mean by central forces? Suppose everything will be directed towards it. Everything will be directed central forces. Now these forces are conservative in nature. This is another word which you will be seeing. Conservative in nature. Suppose this is you are in a gravitational force field. You start from here, you take any path and you come here. Fine. So it will only depend, or you go use this path. It will only depend on the initial coordinate. You know the coordinates x1, y1, z1. I'll tell later on do problems on this. Then you will be clear with this. All this. Later on we will do problems in electricity and magnetism, because electricity is also a gravitational force field. In that also we will be doing work, and it will depend on your initial and final coordinates. It will not depend on which path you take. You take this path or you take this path. It hardly matters. It depends on the final position, which is the coordinate x2, y2, and z2. It will just depend upon this coordinates, all that, the initial and the final point, nothing else. Supposing in this conservative force field, what you do is that you start from here, you go whatever you like, you come back to this point, then the work done will be zero. The work done will be straight zero, because the initial and the final point will be same, and therefore work done will be zero. And very interesting thing I like to tell you in this, the force can be derived is out of potential. This is, I've already explained you derivatives in my lecture 3 of this video earlier. So F is derivable from potential. This is something very important. This is important for conservative force fields. conservative force fields, whether it is electromagnetic or it's gravitational. This equation holds for both conservative force field. Now see one more thing. Let me tell you one more thing about this. Now you may have seen this in your house a wash basin. Let's draw the wash basin like this. This is a wash basin, and this is your tap. Suppose you fill this place with water, and you suddenly remove this opening. The whole thing will rotate in this manner. Will go down into the sink. But in a conservative force field, it is a conservative force field is irrotational. It does not rotate. Irrotational. Conservative field is irrotational. This is very, very important. Conservative field is irrotational. Conservative field. Let me write it somewhere here. Conservative field is field is irrotational. This is very important. Let me repeat what I said here. Let me redraw the figure for you all and see. This you may have done this type of experiment in your childhood. This is your basin. This is your basin. You may have filled with water. You have closed this place from where the water goes out. Let me take more space. Let me take more space. The water goes out of this place. This is your pipe. From the water goes out. You open up your tap. This is your tap. Something like this. The water fills. The water has been filled. Suddenly you move this. The whole water will take rounds like this, and then it will come out, go down in this manner. So this curling of this rotation happens only in non-conservative fields. This rotation, and in being this a conservative force field, this type of rotation won't happen here at all. It is irrotational. That's what I mean. Now, whatever I told you for gravitational is valid also for the electromagnetic. You can stop this video and start writing. Only there is something different here. See, the formula looks the same, almost the same. Instead of G, you have 1 by 4 pi epsilon naught, whose value I have already given here. And G's value I have already given here, which you have been seeing from class 9. And this you have seen in class, I remember in class 10th, you have seen this in the first or the second chapter, this equation. So nothing new in this. Nothing new. So this is permittivity of free space. This is pronounced as epsilon naught. Let me write down. Some people may have some problem understanding what this symbol means. So this is, or may have forgotten, that's the thing. This is epsilon. Let me write. This is to be pronounced as epsilon, and there is a naught here. So you are going to write this as naught. Pronounce it as naught. N-A-U-G-H-T. Naught. Something like that. So it is a knot out there. Wait a minute, let me rub this. No need of this, otherwise you will. Yes, now let me. Epsilon naught. Now, knot is okay. Now let's see the weak nuclear force. Something that is. See, it is a force that only happens inside the nucleus, but it is very strong. But it is quite strong. Now, this is very, very strong. And this happens in, say, let us talk about, I don't know why this is coming. Wait, yes, now you can see. Now, this happens inside the nucleus, especially it happens in radioactive elements, radioactive things which go for beta decay. See, you may have read about radioactivity a little bit in class 10th, that if you have a substance, oh, wait a minute, if you have a substance, radioactive substance, either it gives, there is a decay of gamma or an alpha decay or a beta decay. Beta is a negative decay, and this is a positive decay, and this is a neutral. This is a neutral decay. So, in case of a beta decay, in case of beta decay, this basically happens in order to conserve the linear momentum, because what happens is that the beta goes like you have seen in that recoil of a gun, the bullet goes forward and the gun goes backward, right? And the gun goes backward, but here the problem is that the beta particle goes forward, the nucleus goes backward, but still the momentum is not conserved. It was, I think, Wolfgang Pauli who found out that there is something called elementary particle called neutrino and antineutrino, which basically balances this conservation of linear momentum. Nothing more is in this. You just have to remember these points. When they ask us in the examination, just write them down. Nothing more you have to do. This is the strongest force in nature. They are the very short range and operate in nuclear level. Can you see this? 10 to the power of minus 15. How much less it is? I'll just make you understand. See, One, you are talking about 10 to the power of minus 5, 15 meter, 15. That means this is equal to 1 Fermi actually. 1 Fermi. It is named again in the name of famous physicist Fermi. Okay, I'm forgetting his full name. That's it. Now the thing is, now understand what is 10 to the power of minus 15 meter. Now see this. Whatever meter you have, you take 1 and then put 15 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You put 15 zeros. One part of this much meter it is. So small it is. And let me tell you one thing in this, basically, wait, let me, yes, oh, sorry. This strong nuclear forces. Now let me rub this conservative, this otherwise you people will. This is nothing to do with conservative here. Wait, let me rub all this now for you. Let me rub all this. Now you have only this thing to remember. Now see, in strong nuclear force, what happens is that, let me explain you a little bit more. They are not central. They do not obey inverse square law. These are very strong, very strong. Now why they are strong? Let's understand the reasoning here. See, you already have the idea of nucleus and atom and everything. Was your atom. This was your nucleus. Wait. Make it a little bit more big. This was your nucleus. I'm making it very big. This was your atom. These are your electrons moving around. You already know about this in your smaller classes. There are protons here and neutrons. Nothing else here in this. You already know like charges repel. Then the nucleus has so many protons in it, it should disintegrate. It should disintegrate. Just a minute. Just a minute. Wait a minute. This wait, I don't know why what happened. Just a minute. Some mechanical problem with this pen. This, oh, wait a minute. This disintegrate. But the thing is this: what happens is that before when these two protons come very close to each other, they exchange a particle. See, this theory was given by a Japanese scientist called Yukawa. Yukawa. I don't know how I'm writing the spelling correctly or not because these are all foreign spellings. He talked about a meson. Meson. This is not to be. I'm talking just to make you understand why this is the strongest nuclear force. There is a elementary particle called meson. There is one neutral meson. There is one positive meson and a negative meson. Now listen what happens. See what why they are so powerful. See, had these forces not been there, then this being two protons together, it would have by electrostatic forces they should have got disintegrated because of repulsion. Due to repulsion, these two protons should have gone away from each other, and the nucleus wouldn't have existed. Protons would 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 have repelled each other, repelled, and the nucleus Wait a minute, let me write it clearly. And the nucleus disintegrated. Now the point is here. Now what happens is that there is proton and a proton and say some neutron here. The moment this comes very close to this, it will give out a particle pi minus meson. You apply plus meson, it will become now, wait, let me take, now see, this will become proton, this will become neutron, and again this will become proton. When they two will come together, then what will happen? And another neutron, let me take, or something. Whenever a proton goes to neutron, it gives out pi plus meson. Whenever a neutron becomes a proton, sorry, it gives pi minus meson. Extremely sorry, it gives pi minus meson. Just a minute. It is pi minus. It giving out, it's taking something, then it acquires pi plus, and when it is neutron to neutron transfer, it is a pi neutral meson. So this is how this the moment they come very close to each other, the moment that these two protons comes very close to each other, they will give out pi minus. It will behave like a neutron, so the repulsion will end. The next neutron will become a proton. Again, when the repulsion will start, again this process. This is a continuous process, always happening. It never stops. So this is why these forces are very, very powerful in nature. Wait, I don't know. Wait, yes. So this I explained to you here. Though you need not write all this in your examination, what you need to write is only this. Whatever I'm putting it here. Hold the video and write down these points. Now we are going to talk about centripetal force. This is a pseudo force, that is, it is not a force by itself. It is due to some other force. This is a pseudo force. This is a pseudo force, and it is not due to by itself. It's not due to by itself. It's due to some other forces like electromagnetic or gravitational. The reason is that they are due to these forces. This centripetal force comes into play. Electromagnetic forces are like tension, like friction, thrust, and all this. So this force is actually required to make a body move in a circular path. Now you see the earth revolves around the sun. The earth revolves around the sun. There is a gravitational force which gives rise to the centripetal force, and this centripetal force balances the gravitational force. Therefore you get your therefore the earth moves around the sun. Now let's understand how this happens. Okay, yes, you have this gravitational force is equated to this F. That means centripetal force, let's call it Fc. So you have gravitational force as mass of the earth, mass of the sun, and the distance of the earth from the sun, center to center distance. And this is your mv square r. So this r is also the center to center distance from earth center. Earth, this is our earth. Wait, this is our earth, this is our earth, and this is our sun, and this distance I'm talking about, this distance. So this r cancels out with this r. So you get g m mass of earth, mass of sun, the distance between the earth, and you get v square equal to this. So you can calculate the velocity of the earth around the sun. It comes out to velocity of the earth. Let me write earth. Let me write earth. Wait. Yes, earth is nothing but under root of GME, mass of earth, mass of sun by the radius. Now you see one thing here. I have written V is equal to R omega, and then again I have written this same formula as this one. Now how does this formula come around? Now see, suppose a body is rotating here in this manner. This disc is rotating. The angular velocity will be in this direction. This is the radius of this disk. This is the radius of this disk. This is the velocity which is tangential to the disk. Velocity V is equal to R omega. Now you see one thing. Now you see one thing in this, that F, you have F equal to mv square by R. Put this value of here. This becomes m r square omega square upon R. You cancel this R with this. You get m r omega. So one formula is this. The other formula is this. This omega is called the angular velocity. This omega, this v is called, let me write down, v is called linear velocity, and this omega is called angular velocity. Angular velocity. Wait a minute. Angular velocity. Angular velocity. This is called angular velocity. I hope you have understood the relation between these two. Now the next point is, let us understand the centrifugal force. Now this is always tangential. See, so what you do is that you tie a rope, you do one thing, you to a rope, to this rope, you tie a stone here and revolve it. So the moment you leave the after revolving, you leave the stone, this rope, this stone will fly in this direction. So this is called the centrifugal force. This is the due to which this due to the centrifugal force, this will fly in this direction tangentially to the path. Suppose it's taking this path rotation, and it will fly in this direction. Suppose you leave it here, then it will fly in this direction, and this is due to centrifugal force. And this too has the same formula as this too. And this is the reaction force of the centripetal. That's all. Suppose the day the Earth's gravitational force stops, then this formula will not work anymore. Let's see. Here, this, suppose the gravitational force is removed from the Earth, then instead of now the centripetal, you will use the same formula, but the Earth will fly off. See, the earth is this is the sun, and the earth is moving in this direction. Due to centripetal, it is in the attraction, because gravitation and this centripetal force is in this sense. And the moment the gravitational force stops working, the stops working, this will fly off, the earth will fly off in this direction, or if it stops working here, it will fly off in this direction. This is due to centrifugal force. Centripetal is the action, centripetal is the action force, the action, and the centrifugal is the reaction, and it acts on two different things. Now, let us see some more things now of your syllabus. That is your angle of friction. Let us define angle of friction. Let me draw a line here. Wait a minute. The line has been drawn. Now, first topic, angle of friction. Angle of friction. First understand it, then I'll write the definition for you. Suppose this is the body. This is moving with a force F. There is some friction here. So I can parallelly move it according to I told you in the parallelogram of force addition, this is the frictional force, this is the weight, this is the normal reaction. The resultant that between this and this force is somewhere here. The resultant is this. The resultant which makes with the normal is called the angle of friction. So let's write it down. The angle of friction is what the resultant, here see I have used the word R for resultant and N for normal purposefully. The angle of friction is what the resultant force between the normal reaction and the frictional force, this frictional force and frictional force makes with the makes with the normal reaction, normal reaction. Let me draw this figure. Now let me draw the FBD of this free body diagram. Now this is your force, this is your friction, this is your weight, and this is your normal reaction. Let's make it big. And this is your resultant. Now this is the angle which it makes. Now if you move this parallelly and put it here, it becomes something like this. So now your tan theta is tan theta is, now this is your perpendicular, this is your base. So perpendicular is F and the base is normal. Now F, you know what it is, mu S n upon n, they cancel out and this becomes mu S. So tan theta becomes equal to mu S. That is what is angle of friction. And the angle of friction you need to find is theta equal to tan inverse, wait a minute, tan inverse, theta is tan inverse mu S. Now you need to find this, you will get the angle of friction. This is what is angle of friction. The angle of friction is this angle, this angle. Now the next is angle of repose. Next is angle of repose. Let us write down. Let me draw a line. Angle of repose. The angle of repose. Now what is this? Suppose, now you already have seen this diagram earlier also. You have already seen this diagram earlier. This was my slope. This is the slope. This is theta. This is the body. mg. This is the normal reaction to the surface. This is a straight surface. By mistake, the line got a little bit shaky. Now this is your theta. You know why. This is 90. And you know how to find the angles. Now this is the normal reaction. This is mg cos theta. This is mg sin theta. You now know everything from the previous videos. This is your friction. It is trying to slide down. Now, see one thing. See, now I'll explain you what is the angle. Now let's not call it theta. Let me call it some other angle. Then you will be able to understand. Let me call it alpha. So this is going to be alpha, and hence this and this are going to be now alpha because I've taken this as alpha. This is as alpha. Now the minimum slope that I need to give to this so that the body would just slide. I'm saying just slide. Let me write down the minimum elevation, minimum elevation, elevation I needed to make the body, this body mass, this mass I'm talking about, make the body slide down the slope, slide down the slope is the minimum elevation, that is alpha. This alpha need to make the body slide down the slope is called angle of repose. Angle of repose is angle of repose. Now see what I do is this. Let's again basically let us now sorry yes, let me keep the figure at least. Yes, now I have to write down the equation of motions. So before I write down, okay, let me redraw the figure. The figure is something like this. The mass is here. Okay, this is my alpha. This is my weight. This is my normal. This is my normal, and this is my mg cos alpha. This is my friction, and this is my mg sine alpha. Now, see, n in this direction, it will be equal to mg cos alpha, and you have this f minus mg sine alpha is equal to m into 0. 0 because the body is just slides. Remember, just slide. This is the concept. Just slide means acceleration is 0. Therefore, this whole thing becomes 0. And you have f equal to mg sine alpha, right? And you have n equal to mg cos alpha. Now, f you already know. Now, let's write the equations in this manner. Mg sine alpha, let's divide the two equations. Mg sine alpha divided by mg cos alpha is equal to f upon n. Now, f is mu n by n. So, this cancels out with this. This cancels out with this cancels out. Sine upon cos is tan alpha is equal to mu. And right now we saw mu was what? Let us see. Mu was what? See, this is means mu as we just saw this mu as tan theta. Mu we saw as tan theta. So I will be using this here expression. So mu from the above expression is tan theta. So now you have alpha equal to theta. So at this angle, when alpha will be equal to theta, the body will just slide, and this angle alpha is now called the angle of repose. Angle of repose. So in numerical sense, angle of repose, in numerical sense, angle of repose in numerical sense is equal to angle of friction, angle of friction, angle of friction.